Nicolas, how are you?
I'm fine. Well, I'm at home, probably like most of you.
Like the rest of us, absolutely. And whereabouts are you? For anybody tuning in that doesn't know where home is for you, where is that?
I'm living in France, but close to Geneva, so very close to the Swiss border, which is close at the moment. That feels very funny because I've been working there for like 12 last years, and now I cannot go there.
Yeah.
So it's very strange. I mean, very strange times.
It's very strange for everyone, and everyone's getting used to staying at home. But it's a worthwhile thing to do, and we will have to do so. And hopefully, we'll see some positives at some time soon. So, Nicolas, if you could share your screen,
yeah, sure.
I will get that readied and hand over to you for the next session. Great stuff. So let's add that in. There we go.
How does it work for you?
That's looking good to me. Great. So without further ado, I'm going to hand over, and I think you get the added bonus of an extra minute. So let's do this. Let's kick off now, and we'll speak to you afterwards with some Q&A.
Okay. Thanks, Mark. So thanks everybody to be here. I just listened to the half of the last talk. It's very hard for me now to start because I will be trying to do something serious, and the last session was so fun that it's going not to be easy, but I will try my best. I'm Nicolas Fränkel. For nearly the last 20 years, I've been working in software. I was a developer, I was a team lead, I was an architect. A couple of years ago, I decided to become a developer advocate. And being a consultant, you do a lot of serious stuff again, and you have deadlines, you meet them sometimes, well, hopefully, but you are always trying to bring business value. Whereas I wouldn't say crazy, but I'm pretty creative. And so being a developer advocate allows me to present you some crazy ideas that I've had. So this talk is one of them. I work for a company called Hazelcast. We have two products. The first one is called an in-memory data grid. And basically, in a few words, it's just like a bunch of data structures that can be distributed over the network. So you have an API, which looks like, for example, a map, but then the data is all over the network. And the second is Jet, which I will have a few words afterwards. So I will be very fast on that. Let's start by talking about something that most of you know, continuous integration. Continuous integration, in the legacy way, is, well, you integrate all your code together, you merge all your code from developers together, then you compile it, you check that it compiles, then you do your test, you check that the tests run, then you package, then you do some integration testing, perhaps you do some containerization, you store it in the registry. And in general, this is the good stuff that everybody should do. But since more than a decade, some companies have been trying to do better, to go further. So continuous integration, probably everybody does it. At least everybody should do it. A continuous delivery is much harder because it means that you need to put the artifact at the right place until somebody decides, hey, let's make it real, and then press the button, and then it's deployed. And if we go even a step further, we have continuous deployment. So in that case, we could say that a commit directly after the end of the continuous pipeline delivers it into production. And the end goal is to have no manual decision, everything is automated, and of course, there is no downtime. I'm saying continuous integration and continuous delivery and continuous deployment. You might see CI/CD a lot in a lot of different places. You should be very, very cautious about that because, as I mentioned, continuous integration should be a given, and it's pretty much industrialized today, continuous delivery and continuous deployment, they are very hard, and not a lot of companies do it already. And so the traditional deployment model on the JVM is, well, you stop the JVM, whether you are running a fat jar or running an application server or just even a servlet container. You stop the JVM, you take your new artifact, you rewrite the old artifact, and you start the JVM again. And if you have been working for like a traditional company, that's not an issue. You have a web server, a proxy, then you set like a little screen saying, hey, sorry, we are down for the moment. But unfortunately, it's not super cool now to do that. Like, for example, Gmail or Facebook, or I mean, every application of those big companies, they are not allowed to have downtime. And a lot of people, they are expecting your application not to be down at any point in time. Also, the problem is if you are like selling stuff, for example, if you are an e-commerce shop, then every second, every minute of downtime is a second or a minute you don't sell, where potential customers, they go to buy elsewhere. So you in general, you want to be always up. And of course, there are ways to do that. We have been talking about like Bluegreen deployment for a long time. So the gist of Bluegreen deployment is you have two completely similar environments. One is green, the other one is blue. And then at some point, you will just switch the arrow from the green to the blue, and the blue one will become your new production environment. It's not that easy, of course. The problem is always in the database, because then there are two ways to handle that. Either like you keep a copy of the data on each environment, but then when you switch the arrow, you must also copy all the data from one environment or the other, or you keep a single database, but then the question arises, how do you handle schema changes in your database if you have a SQL application? Well, there are a couple of issues. They are possible to manage, but it's a lot of work. Kubernetes decided to make everything easier. Then you have these rolling updates. Then you can have those nodes, and then they can be updated like one after the other. But in the end, still you have an issue with the database. So this is not easy stuff. This creates problem in the delivery pipeline. Like your developers, they need to handle those schema changes, and then the project managers needs to schedule them. It's not an easy problem. So I have this crazy idea that what if we could change the bytecode of a running JVM? So the JVM just keeps running, and then the class is reloaded. And yeah, we shall try to do that. But before we go in the demo, I need to tell a bit about how it works. So first, there is something that's present in JVM called the attach API. And the attach API allows you to load an agent. So I will go a bit afterwards into the agent part. I think there was a talk before about agents, so probably some of you already know about it. But basically, it's just a piece of code that you will attach to another JVM. So you will just put this agent into this other JVM. And the good thing is you don't need to run this original production JVM. Your application doesn't need to run in debug mode. It can run in standard mode. Of course, you have requirements, and there are two requirements. The first is you need to run on the same system. It can be a container, it can be a normal machine, but it must run on the same system. And the second requirement is you must know the PID of the JVM you want to attach to. The attach API is pretty simple. Basically, you have this class where you say, oh, I need to get a handle on the virtual machine, and afterwards, I need to load the agents, and this is done. So there are a couple of, implementation for each machine. Here on my own, I have a hotspot virtual machine. I will show you how it works. And then afterwards, you need to run this agent. And agents, they are jars, like simple jars. So this is Java bytecode with specific metadata. And they are part of the Instrumentation API that allows you to change the bytecode of running application. There are two kinds of agents. The first one, probably most of you know about them because they are set at startup. And that's how a lot of monitoring tools work already. So instead of calling java.jar your jar, you have this additional parameter called -java agent, and you set the path to the jar. And when it starts, then the agent will run its magic. The thing is, it can only be run when you start a new JVM. So that's why it's called static. Now, our issue is we already have this JVM running and we need to do stuff on it, like to load new code. And this is the dynamic agent, and this is loaded by the attach API. As I mentioned, you have like an agent is just a simple jar where you have additional metadata. So in a normal jar, as this main class. On the static agent, you have a pre-main class, and on the dynamic agent, you have an agent class. And then you've got an entry point where you want code to run when the agent is triggered. On the static one, it's called pre-main, and on the dynamic one, it's called agent main. For the rest, there are regular jars, so you can have like Java agents, you can have Kotlin agents, you can have Clojure agents, you can have whatever you want agents. They are just like jars. Instrumentation. So once you've got a handle, here you have this like interface called instrumentation that is passed by the JVM, and you can do pretty cool stuff with that interface. Basically, you can change a class implementation. There are some limitations. I will come back to them later. And also, every time you receive bytecode, you can do automatic transformation. So here is a little class diagram. You see this is what you will receive from the pre-main or the agent main static method. And you can add a class transformer that's like apply automatic transformation of the code, or you can do something very cool called redefine class. And that's what is interesting. So basically, you will have a class that is already loaded, and you will put the new byte array of the bytecodes to this class. And then the JVM will reload it on the fly, will redefine it on the fly. And now we have a last issue is imagine that we want to do this continuous deployment. So we need to move the bytecode from, let's say, our machine to production. One way to do that is to do batching. So let's say like every 5 minutes, we will take bytecode, put it in production. The issue with that approach is that, well, sometimes we don't have nothing to do. So every 5 minutes, we will put stuff that is not really interesting. And otherwise, we might change every minute, and then we will get only the last changes from 5 minutes. So instead of doing batching, it's better to do streaming. The good thing about streaming, it's uninterrupted. It takes the changes as they come, and they flow regularly. And if you have been doing reactive programming or event-driven programming, that's exactly what we want to do. There are a lot of in-memory stream processing engines available. There are some that are available on the cloud, so every big cloud provider has its own, but you can also have open source products that you can leverage. So at Flink or Jet, you also have this Apache Beam project, which is quite interesting because it tries to abstract under an additional API some of the above. Well, the issue is that since it's not a standard, like stream processing is not a standard, and not everybody cooperated with Beam, then it's a very leaky abstraction, but I think it's a great idea anyway. So you have all the stuff. And because, I know better Hazel costs, I can talk to you a bit about Hazel costs, but most of them work in the same way. So we are Apache 2 license. It's a single jar, and you can do batching or streaming in the same API. And this is basically what a streaming engine does. It takes data from sources, it reads them. You can read from several sources and try to combine them together. And then because you do streaming, you might want to do aggregation over windows or rolling windows or fixed time windows. Then you can do some computation and transformation, and then you write them in sinks. And if you have been doing ETL, extract, transform, load in batch, then you do the reading part, and then you do the transform port, and then you do the writing port, all the same. So by doing streaming, you have other capabilities that are not leveraged in what I will show you, but they might be interesting anyway. And this is my design. This is what this crazy AD is all about. So I have my source class that will get generated every time I change my source.java. Every time I compile it, then I will create this source.class. And I have a jet job that runs into a streaming JVM. And every time it detects a change, it will put it in a data store. In that case, it will be in-memory data grids, but you can put it anywhere. And afterwards, I have my production JVM, which runs its own app, like in its own edge of the world. I will take this injection JVM, I will take the path to the jar, and using the attach API, I will make it so that here, this app now will be registered to all changes that happened in the data store. So every time the job puts new data, which in that case is bytecode, into the data store, then the app will be will listen and then will be notified, and then we'll be able to redefine it. Here is a little sequence diagram. So I have first, I need to start the jet job that will just loop over reading all classes, and then if the bytecode has changed, put the bytecode into the data store. And then I will load the agents, which will attach itself to the production JVM. And the production JVM, as I mentioned, will subscribe to changes from the map. So every time there is a change, then it will read and redefine the bytecode on the fly. And perhaps I have some time for a demo, because I try to be very, very fast. Do I have some time for a demo?
Yeah, absolutely. I believe
Perfect.
Looking at the schedule right now, you have another 15 minutes.
Perfect. That's good. So I have these projects, and here is my production JVM. So I have a hello servlet. As you can see, so I'm running the normal stuff, and the production servlet will just do local well, forget about it. I will just be much, much faster like that. Here, it says hello world. It says hello world, and it's running, and I'm happy with my production. Now what I will be doing is I will be running my jet job again, normal stuff. So no debug. So now I have a jet job that reads class files, and every time it sends the class file results to the output, and also if there is a change, it will put it in the IMDG, in the data store. And now the magic happens here. I have this attach API. So this attach API will attach itself to the production JVM. And it has run, and it's finished. Now we can see that the main the stupid servlet now seems to have been doing something strange. There is like hassle cost related logging. Now so here is the work. This is my production. I shouldn't access it. What I will access is the copy of the production. This is what I want to change. This will get compiled. This will generate the class file. Jet will read it, will put it in the IMDG, and then the final production JVM will redefine the class. So if I say hello, all the folks online, and now I just compile it. And if I curl again, it's done. So I have changed the code live, and the JVM was never down. So perhaps since I have a bit of time, I can show a bit of codes, stuff that might be interesting. So the attach API here, the usage is very, very simple. As I mentioned, you need to attach yourself to a JVM and then to attach, sorry, this is Kotlin, but this is exactly the same. So you need to attach yourself. You need to pass the PID. And because I'm super lazy, instead of checking every time the PID, which wouldn't be super feasible, is I just use the process handle and to filter the one PID that has this main production class. So this is how I get the PID. And then I load the agent. And the agent has already been compiled. So here you can see there is this update agent jar. This one comes from here. My computer is a bit sluggish. It's not you, it's me. And here you see the agent main method that I talked about. You see the instrumentation here that I'm using that is passed for me. And what I'm doing is I will create a client of this just job. And every time there is a change on this like map of bytecodes, then I will call this entry listener. And this entry listener is past the instrumentation. And basically what I'm doing is I will get the key. So in this map, the class name is the key and the key value is the bytecodes. And I will just use it, create a new class definition, put the class, put the bytecode, and redefine the class. Finally, what I need to do is to have the job itself. So the job itself is here. I define the pipeline. And if you have been doing some Java 8 streams, it reads very fluently. So you read from something called classes, and classes is the way to access, well, the bytecodes. So here you have something called the class path reader, where I read every time I read the file system, and then I stream all files that it has detected. What I do not to override my pipeline is I only stream changes. So once the bytecode has been loaded into the IMDG, then it knows where it is and I check for change. And if there is no change, I don't stream it downwards because it would be very stupid to redefine classes with the same bytecodes. And here you have all the gist of it. And now there are like perhaps some questions. I will just finish the slides because this is not the end. So this demo is just a crazy idea. It's a demo, it's a POC, it's a prototype, call it however you want. There are limitations. If you come from a world where basically you have jars and you tag them and you version them and you say, I know this version 1.0 is in production, it will feel very strange to you. Now the issue when you start doing continuous deployments is you don't have this mindset, oh, here I have version 1.0 in production. Probably what you have is up to a commit in production. This is a change of mindset, which I agree is very, very hard to do. The instrumentation API allows you to load new classes here. I didn't do that because I've been lazy, and you can do it on your own. There is a very hard definition of the redefined classes. It tells you cannot add or remove fields or methods. You can not change the signature of method, or you cannot change the inheritance hierarchy, which for me, it's very constrained, which means still that you can actually change the body of every method. It still gives you a lot of power. Something I didn't try it, but having the attach API is, of course, a security risk. So you need to be clear about that and to think whether the pros are bigger than the cons. We can do some improvements because, of course, the goal is not to stream for the developer machine because you might have many developers. You can combine what I showed you with your CI pipeline, with your continuous integration pipeline. So instead of streaming for the machine of the developer, you can still commit to Git, then it gets compiled, tested, whatever, until what you wanted, and then the folder at the end will be the source of the stream. And of course, you can also be wanting to add additional metadata in each class in that case, so you can still have Git tags, and then you can like transform each time you load the class, or even during streaming, you can add this additional metadata. Also, what you can be doing using streaming is add like a secure stamp so that the JVM that loads the new bytecode knows it comes from a secured source. So thanks for your attention. You can read my blog, you can follow me on Twitter, and more importantly, you can get the repo. Everything is on GitHub. So if you have also crazy ideas of improvements or whatever, well, you're welcome.
Great stuff. Thank you so much, Nicolas. So
liked it.
Yeah, there's some resources blog there that you can go to if you've got any questions that you haven't posted at the moment. It looks like you've done such a good job that you've answered everyone's questions before they've asked them, which is always a bonus as far as I'm concerned. Out of interest, so if people want to learn more, obviously they can go to your blog. Are there any other resources that you found helpful that you might want to share with people?
Yes, of course. The attach API, the instrumentation API, the blog post, because I always try to write a blog post before doing a session, is under review right now. If people are interested, then I will tweet it when it's published. And in the blog post, there are references to all those like API that might be interesting.
Great. So something has just come through the stream that Grace has just picked up on. I can't see it. And it says, is your listener or agent? Ooh, actually, I'm not sure.
I can read Slack if you want.
I am not sure how to phrase that, but it's basically with regards to overheads on production.
Do you know where where the question is? It's not on Slack.
I am trying to find it right now. It says, is your listener or agent will not make any overhead on production. It's actually in the Slido stream. Okay.
So of course there is always overhead. I mean, if a listener is just like a thread, that constantly checks. So basically, yes, of course, there is a slight overhead. I mean, it's up to you. It's like monitoring your application. It's overhead. But in some cases, I would say monitoring in most cases, it's better to be a bit slower, but you know where you are going instead of going very, very fast. Here, there are pros and cons. As I mentioned, I don't think a lot of people will require this. A lot of people are still used to doing this like downtime and now uptime again, stopping and starting the JVM again. But if you want to have code deployment with no downtime, I guess this is a pretty cool prototype that you can build on.
Cool. Thank you very much. Cheers so much for joining us today.
Thanks for having me.
Hey, no problem. Thanks so much. And in a second, I'm going to bring in Grace. And thanks, Nicola. Take care.